Question 3 tells us to find the equation of the plane passing through the point 1, -1, and 1, and which contains the line of intersection of the planes x plus y minus z equals 2 and 2x minus y plus 3z equals 1. So the first thing that we can do is we can find the normal vector to the first plane of intersection, which is just the coefficients of in front of the x, the y, and the z. So we have 1, 1, and -1. And then the normal vector for the second plane is the coefficients in front of the x, the y, and the z for the second equation, which is 2, -1, and 3. Then, to find a point on this line, we need to set z equals to 0, and therefore that way we can find the x and y values. So when z equals 0, we have the equation x plus y equals 2 and 2x minus y equals 1. We can solve for x in the first equation, so we get x equals 2 minus y. So we can plug this into the x of the second equation. So we have 2 minus y equals 1, which we get 4 minus 2y minus y equals 1. Minus 2y minus y is -3y. And then subtracting the 4 on the right side, we get 1 minus 4 is -3. So we get y equals 1. So then we can plug this value of y into either of the two equations. So I'm just gonna plug it into this one. So we get x is 2 minus 1. So x equals 1. So therefore we found a point of intersection which is 1, 1, and 0, which can be written as a vector form. So 1, 1, and 0. Since these two vectors are perpendicular, we can find a new vector by doing the cross product of the two. So we can do the cross product of 1, 1, -1, cross product with 2, -1, and 3. So we have 1, 1, -1, 2, -1, and 3. So we can find I, which is 1 times 3, which is 3, minus -1 times -1 is +1, so -1. Then we have -j, which is 1 times 3, which is 3, minus -1 times 2 is -2. And then we have k, which is 1 times -1, which is -1, minus 1 times 2, which is 2. So we get the vector 3 minus 1 is 2. 3 plus 2 is 5, but since j is always negative, we have -5. And then we have -1 minus 2, which is -3. So we need to find another direction vector of the desired plane. So we can find the second vector by taking 2 points on the plane. So we take the point A, let's call A the first point that we are given, which is 1, -1, and 1. And then we have the second point, which we found. Let's call that point B. We have 1, 1, and 0. So we can subtract point B from point A, which gives us 1, 1, 0, minus 1, -1, and 1, which equals 1 minus 1 is 0, 1 minus -1 is 2, 0 minus 1 is -1. So therefore we found the two normal vectors, which is v1 here and v2. So we take the cross product of the two normal vectors. So v1 cross product with v2 equals I, j, k. So we have 2, -5, -3. And then we have vector 2, which is 0, 2, -1. So that we can find the I component, j component, and k component. So we have I, which is -5 times -1, which is +5, minus -3 times 2, which is -6. Then we have -j, which is 2 times -1, which is -2, minus -3 times 0, which is 0. And then we have k, which is 2 times 2, 4, and then negative 5 times 0, which is 0. So we get the vector 11, positive 2, positive 4. So using the formula r minus r naught times the normal vector equals x, y, and z minus the first point that we were given, 1, negative 1, and 1, times the normal vector that we found, 11, 2, and 4. So then we get 11x minus 1 plus 2y plus 1 plus 4z minus 1 equals 0. So we get 11x minus 11 plus 2y plus 2 plus 4z minus 4 equals 0. So we get the equation of the plane to be 11x plus 2y plus 4z minus 13 equals 0.